Hey guys, what's going on? In this video, we're going to be creating a dApp or decentralized application that interacts with a Faucet smart contract on the blockchain. This application basically allows anyone with an Ethereum address to request tokens. The front end is based on Reactjs and will also be using Ethersjs as well as the Metamask Ethereum API to interact with our wallet and the blockchain. So if that sounds good, stick around and let's get into it. So a few things to cover before we get into coding. First of all, this tutorial focuses on building the client-side application. If you want to build out the Faucet smart contract, I have a separate video that goes through that step by step. So please check that out, or you could also just use the contract that I deployed to the test network as well. And you'll see how to do that in this video. Also, there's an optional starter repo for this tutorial that you can clone from my GitHub account, which is basically just a plain vanilla create React app with some added HTML and CSS, as well as a connect wallet button. If you want to see how to create the connect wallet button step by step, I have a video for that too, and you can find the link to that tutorial in the description of this video. Also, if you have your own project that you want to use and integrate the code from this tutorial into it, that's totally fine as well. Alright, so I've opened up Visual Studio Code and I've created a new folder for my workspace and gone ahead and opened that within Visual Studio Code using the open folder link right here. So the next thing I'm going to do is open a new terminal window and I'm going to go ahead and clone the starter repo. And again, this link can be found in the description of this video. So I'm going to go ahead and clone that. That should just take a couple of seconds. And once that's cloned, I'll do ls to see what I've got here. Okay, I'm going to cd into that directory. Faucet dApp starter code connect wallet, and I'm going to go ahead and right off the bat install the dependencies, so npm I for install. That'll take a couple of minutes, so I'm going to go ahead and pause the video and come back once this is complete. Okay, so our dependencies are installed, and the next thing I want to do is I just want to do a npm run start, just so we can kind of take a look at our starter code and see what this app looks like, and just make sure that the basic functionality is there. So again, I'm going to run npm run start, and that should open up the application in a new browser window at localhost 3000. All right, so here's the app. Here's our starting point, and pretty basic. It's got a connect wallet button, so this should work at this point with the starter code. So I should be able to go ahead and connect my MetaMask wallet. And then as you can see, there's an input for the address, which we're going to populate automatically once the user logs in. Okay, so you can see we're connected up here, and we're going to have to implement the display of the address down here. We've got our get tokens button that's going to invoke the request tokens method on our smart contract, and then we'll show some of the transaction data like the transaction hash down here once we're done. And that is basically it. So yeah, just make sure that the connect wallet button is working, and that should give us a good starting point. All right, I'm going to jump back into Visual Studio Code from here. All right, so I'm going to go ahead and stop my server by hitting Control-C on Windows. There we go. And so the next step is going to be to install the library that we're going to use to interact with the blockchain, and that's going to be Ethers for this video. So I'm going to run npm I for install Ethers and go ahead and let that install. So just a word about libraries. There are a bunch of different libraries that you can use in a dApp to communicate with the blockchain. First of all, there's the Metamask injected Ethereum API, and you can actually build a fully functioning dApp with just that library itself. That allows you to get accounts from your wallet, get your connected account, and it can also allow you to do things like send transactions and query the blockchain. However, if you need a little bit more robust functionality, you can start to use third-party libraries such as Web3, which I've used in previous videos, and then Ethersjs as well. And there are other libraries out there as well, such as Alchemy, which initially had a library that wrapped the Web3 library, and now they're using, they've gone more in the Ethers direction. But anyway, there are a bunch of different libraries out there, and there's a lot of overlap in terms of the functionality among these different libraries. But at the same time, what I found is that there are a lot of discrepancies, and their APIs look different. They do things differently. They handle certain things differently. So sometimes it takes a lot of trial and error before you really know exactly which library that you need to use for any given project. And as an example of that, I first built out this entire Faucet dApp using Web3 because I've used Web3 in the past. I'm comfortable with it and I didn't really need anything fancy. But at the very end, I found sort of a bug in the Web3 library that it wasn't allowing me to get the revert reason from the blockchain. Whenever you invoke a function and it reverts the transaction for any reason, your require statement in your Solidity smart contract typically provides some sort of error messaging. And there is a documented way to fetch that error messaging through the Web3 library, but I had a real hard time getting it to work. I did a lot of research around it and found that a lot of people had similar issues. So I decided to just try ripping out Web3 altogether and trying to put Ethers in place. And sure enough, that worked. And I was able to get the revert reason without too much trouble. So anyway, that's just a little aside to sort of talk about the different libraries out there and why you might choose one or the other. A lot of times it won't matter, and you can kind of use any library that you want to. So, all right, with that said, let's go on to the next step here. Okay, so I'm back over in Visual Studio Code, and what I want to do is expand the project, then expand the source folder, and then you should find a folder called Ethereum underneath that. So let's go ahead and expand that folder. And what we're looking for is a file called Faucet.js. So let's go ahead and pop that file open. Now, the main purpose of this file is going to be to create a local instance of our Faucet smart contract so that we can then manipulate it with JavaScript and basically call methods on it from the client side. All right, so the first thing we're going to need is to import Ethers, the Ethers library. Okay, so I'll say import Ethers in curly braces from Ethers. Okay. Now there's a couple of ingredients. We'll use Ethers to create our new contract instance, our local contract instance, and there are a couple of parameters that will take in, including an ABI. So I'm going to set up a new variable for our Faucet ABI. And what ABI stands for is Application Binary Interface. What it is it's basically a JSON representation of the smart contract so that our JavaScript client-side code knows what methods and variables are available in that smart contract. We'll populate that in just a second. And the next thing we need to do is return a contract instance from this file. So I'm going to set up a new function called Faucet contract. Okay, and this is going to take a provider, which we don't have yet. We're going to set that up in a few minutes. Okay. All right, and let's go ahead and export this. So I'll say export default Faucet contract. All right, so inside this function, we're going to return a new instance of our contract. So I'll say new Ethers. Now we're using the Ethers library. Contract, capital C, very important. And this is going to take a couple of parameters. The first one is going to be the contract address. The second one is going to be the Faucet ABI, Application Binary Interface. And then finally the provider. All right, so let's go ahead and populate the ABI and the contract address. So for convenience, I've added two files into the root of the starter code. One is ABI JSON, okay, and just go ahead and Control A, copy the whole thing, come back into Faucet.js and just replace this empty array with the Faucet ABI. Make sure you don't have two semicolons like I do. Go ahead and save that. And then there is a address.txt that has the address of my deployed Faucet contract on the Goerli network. Now, of course, if you've done your own Faucet contract, then you would go into your own project folder and grab your own ABI, and that's under artifacts, contracts, contract name, and then you'll see a file, faucet.json, for example. So you would go in there and grab your ABI, and of course use the address of your deployed contract. So I'm going to go ahead and paste the address right here and go ahead and save. All right, so that's all that we should need to do in our Faucet.js file. We are done here. One thing I'm going to do is actually copy this import statement because we'll need it in our main app.js file as well. So I'm going to go ahead and close these other files, and I'm looking for app.js right underneath the source folder. So let's go ahead and open that up. And I am going to go ahead and see, I'll go under app CSS and go ahead and paste in our ethers import. And then the next thing we want to do is we want to import that Faucet.js file that we were just working on. Okay, so import Faucet contract from current directory / Ethereum / Faucet. All right, and go ahead and save your file. All right, so before we code anything else, I just want to take a quick break and sort of give a brief overview of the next couple of steps, which involves setting up Ethers and creating a contract instance, because this works a little bit differently from Web3 if you're used to that. So the documentation is pretty good for Ethers. And if I go over here under, where is it getting started? I think this is the right section. It kind of lays out the 3 main steps that you need to do. So first, a provider. We need some sort of provider. In Ethers is a class which provides an abstraction for a connection to the Ethereum network. So the good news is here we can just use the window.ethereum provider that is provided by Metamask. Okay, and then we need to set up a signer. Okay, so a signer is a class which in some way directly or indirectly has access to a private key which can sign messages. So we need this for any sort of send transaction or any transaction that's going to cause a permanent change in the blockchain. For example, our request tokens method. So the great thing is we don't need to deal with any private keys in our application. We get that directly through the MetaMask provider. Okay, and finally, contract. This is what we set up in Faucet.js. This is basically a local abstraction or local instance of our smart contract that we can use and call methods on from our client-side code. So these are the 3 things that we will be setting up in the next step. Okay, so the first thing I'm going to do is come down to our connect wallet function and go right in the first try block. And remember, if we've gotten this far, we know that MetaMask is installed because we see window.ethereum is present. Okay, so we can go ahead and set up our provider. So I'm going to say, I'm just going to comment this so we know what's going on here, so it's really clear. Get provider. Oops. All right. So I'm going to set up a new variable provider. Okay, and I'll say new Ethers. We're using the Ethers library. Providers dot web3 provider. And we pass in window.ethereum here. Okay. So we are requesting the accounts right here directly through window Ethereum. Another thing I could do is use the provider that we've just set up directly. So let's see what that would look like. I'm going to say get accounts. And so I could save this to the same accounts variable. Well, I'll delete this one in a second. And I can say await provider.send and then pass in that same method, eth request accounts. So I'm just going to grab that here. Okay, and then the second argument is going to be an empty array. All right, and I'm going to go ahead and delete this one. We don't need that anymore. And the third step is going to be to get a signer. Oh, sorry, this is really the second step. The third step is going to be to create the local contract instance. So I'm going to say get signer. And I think for the signer, we're going to actually use it from another function. So we need to set up a state variable for that. So let's jump up right here underneath our wallet address and let's set up a state variable for signer. So I'm going to say signer and set signer. Okay, so we'll set that from our connect wallet function. equals use state. Okay. So now we can use that setter. And then we can use our provider, and there's a method on the provider called getSigner. All right, go ahead and save that. And the next line down here on line 25, that is simply setting the wallet address to a state variable, and then we're console logging that just to make sure we're getting some data. And then finally, well, I'm going to go up right above that actually, and let's get our contract instance. Okay, so I'm going to say local contract instance. And so let's see, we also want to set this as a state variable because we're going to use it from our click handler that's going to actually invoke the get tokens function. So let's go back up here and create a new state variable. And I'm going to say FC contract for Faucet contract, and then set FC contract. Normally I would call it Faucet contract, but I would have a collision here with my naming, so I've got to settle for a abbreviation. All right, and I'm just going to grab the setter and come back down here to connect wallet. And so we'll invoke, well, we'll set inside the setter, we will say provider, or sorry, we'll say Faucet contract and pass in provider. So remember, Faucet contract, that is the function that we're exporting from our Faucet.js file that's going to actually put together the contract, pass in the ABI and the actual address and things like that. All right, so this takes a provider. All right, and just to show you what I'm talking about here, to refresh your memory, this is invoking this function down here that we set up earlier. So remember, this takes a provider, and then it's going to return a new instance of our Faucet contract. Okay. All right, let's go ahead and save that. All right, so the next step is that we're going to actually have to repeat a lot of this functionality in our getCurrentWalletConnected function, because remember the connect wallet, that is for when you initially come and sign in via Metamask, and then getCurrentWalletConnected, that is sort of if the page gets refreshed, React sort of forgets about the current connected account, but yet MetaMask is still connected behind the scenes, and so we need to sort of just do a refresh, and you'll notice that there's a difference here where we're getting accounts, simply fetching accounts from an already connected wallet, where here we're requesting accounts, which implies that the user needs to actually sign in and sign the request and approve of it. All right, so I'll tell you what, let's copy these first 4 steps here. Get the provider, get the accounts, set signer, and FC contract. Let's go ahead and copy all those, and let's bring it down here. Now I'm in the get current wallet connected, and I'm gonna go right at the top of this first try statement. I'm just gonna paste this in here. Okay. So the first thing I'm gonna do, and bear with me here, this is a little bit messy, a little bit of minor surgery just to get this all working correctly. But I'm gonna grab the ETH accounts and just replace the request accounts with ETH accounts right there. Okay, so now we can delete this function. We don't need that anymore. And so if we get into this try block, we basically know that MetaMask is connected. Okay, and so we're gonna attempt to retrieve the accounts. But then we have a check down here, if accounts.length is greater than 0. So we want these 2 bits of code to run only if we've verified that we do in fact have accounts. So I'm going to cut those from here. All right, I'm going to get rid of this white space here, and then I am going to paste that right inside of this accounts.length check. Okay, so that now everything seems to be happening in the right order. I'm just going to double check this here to make sure this looks good. So if accounts.length is greater than 0, that means if we're connected, and so this means that we have access to the currently connected account, then we go ahead and set the signer, create the Faucet contract local instance, and set the account into local React state. All right, that looks good to me, so I'm going to go ahead and save this. All right, so the next step is going to be to wire up a function, a click handler, that will actually talk to our smart contract when a user comes and clicks on get tokens. All right, so this is going to invoke our request tokens function on our Faucet smart contract. So let's go ahead and write a function for that. And I'm going to come right to the last function and create a new line, and let's create our click handler, and I'm going to call this get OCT, get ocean token handler. Of course, name it whatever you want, whatever sounds good to you. It's going to be an async function. Okay, and we'll set up a try catch block inside here. Oops, I don't need that parentheses. There we go. All right, so I'm going to set up my try catch, and if in our catch that will be passed a error object. All right, and let's just go ahead and handle that really quick, and I'm just going to console log that error message for now. And before we finish, we'll set up some sort of notification areas on the app to show like a success message or an error message. But for now, we're just going to log it. So let's say error.message, or let's just log the whole object. So I'm going to say, oops. Actually, yeah, let's just do error message for now. See if that works. Okay. So back up in the try clause. So now with Ethers, there's a slight difference between from how this works in Web3. Basically, if you want to invoke a function on your smart contract that is a transaction, in other words, that results in a permanent change or a saving of data on the blockchain, then you need to connect with your contract instance with the signer. Okay, so this is something that's abstracted in Web3. You don't have to handle it explicitly. But with Ethers, I kind of like how it's decoupled and gives you a little bit more control if you need it. So we'll basically create another version of our contract instance that is with the signer, okay, in order to execute this function. So I'll show you what that's going to look like. I'm going to call this FC contract with signer. Okay, and then so this is going to invoke a connect function on our, oops, what happened here? FC contract with signer. Okay, so we're going to use our initial local instance. So I'll say FC contract.connect. Okay, and then we pass in our signer. And this essentially creates an instance of our local contract with the signer. Okay, so now we can use this FC contract with signer to send transactions. All right, so down here, I'm in a, let's log the response. So I'll set up a response variable. And then this is going to be an await FC contract with signer. And now we directly call, you know, if you've used Web3 before, you might be used to doing something like this, methods dot, and then your method name. In Ethers, you just call the method directly. So request tokens, and that's it. I don't need to sort of pass in my from address or anything. It's already baked into the provider. So that's another difference between Ethers and Web3. All right, and let's go ahead and log the response. All right, and go ahead and save that. All right, so the next step is going to actually be to set up an on-click event on the button. So I'm going to go down here and find the get tokens button. For me, it's around line 130 right now. And I'm going to set up a on-click and just pass in the name of the function that we just wrote, which is get OCT handler. All right, go ahead and save. All right, so this is a lot of setup, and we are almost done though. We're almost ready to test this thing. But before we do that, I think we should set up some of the success and error handling, because that'll really help us out during our testing to kind of see what is going on. So the first step in doing that is going to be to set up a bunch of new state variables. All right, so let's go down, create a new line, and we got a couple of these to set up. So Bear with me here. The first one is going to be withdrawal error. Withdraw error, and then set withdraw error. And we'll initialize this to an empty string. Use state empty string. All right, and then we'll need one for our success case, so we can just copy this and go ahead and paste that onto the next line. And we'll just change the word error to success. Okay, that'll also be an empty string. And we need one more, and this is going to be for the transaction hash that we're going to display just below the input area. All right, so let's say transaction data, just to be a little more vague, and we'll say set transaction data. And I'm just going to take a look, make sure my spelling is right. Looks good. Use state, and also initialize this to an empty string. All right, so now we just need to update the HTML to display some of these things. Well, we also need to set some of these things. So let's go to our get OCT handler first. All right, so we'll start with the success case. So we'll go right in our try block here, right underneath our console log. And let's set our withdrawal success message first. So if we're here, we know that we've succeeded. At least we think we have. And I want to say, I'll just pass in any string operation succeeded. Enjoy your tokens. And this is your chance to be creative, right? Whatever message you want to see in your app. And let's see, what does it not like about this? Oh, my spelling. Withdraw. Withdraw. There, that looks better. And let's go ahead and set the, so at this point we'll have the transaction hash, so we can set transaction data to, it's going to be under our response object, and there should be something called transaction hash. And we're going to find out in a minute if all this works. This is a lot of coding with no testing, so I'm sure something will go wrong, but at least we'll be able to fix it. And then down here, I'm in my catch clause, and I'm going to set my error messaging. So set withdraw error. And let's say, let's just set this to whatever the error message is. Error message. Like that. Cool. All right. So we'll go ahead and save that. Now let's find a good place in our HTML to output the success and error messages for our withdrawals. And I think that place is going to be right above our input area. So kind of below the title and subtitle, but above the input. So let's say right underneath, right above our address box, this box element right here. So let's create a new div. And let's give it a little bit of padding just to separate it from the title and subtitle above it. So this MT-5, that's kind of a Bulma helper class, helper CSS class. That's going to give it some spacing. All right. A little bit of typing here, so bear with me. So first I'm going to check, withdrawal error, that's what I want. I just want to display this if there is a withdrawal error present, right? So this syntax will look familiar if you're used to working with React. And so if that withdrawal error is present, then we'll go ahead and output that message. Okay, and we'll give it a class name of withdraw error. And this is just going to give it a little bit of coloring that's already set up in the boilerplate CSS, so you don't have to worry about that. And then inside here, we'll simply output the message. Okay. Now we want to do the same thing for success. So we can copy this entire block to save us a little bit of typing. Go ahead and paste it right below, and we'll just change some of the key words here. So I'm changing withdrawal error to withdrawal success. And withdrawal success for the class name as well. All right, go ahead and save that. Let's add a little bit of spacing right after this. There we go. Okay. All right, where else do we need? All right, so transaction data. This is just a placeholder. So this is the part that we can actually replace with the actual transaction hash. So I'm going to delete that placeholder text, and inside this paragraph tag, again, similar approach to what we did before, we'll check for transaction data, see if anything's present. And here we can use a ternary operator. Okay, so if it is present, then we want to output the transaction hash. So I'll just put a little bit of text here to signify what this is going to be. And then inside here we can say transaction data, and that should contain the transaction hash. Or clause, let's just like do a double hash like that to indicate that there's no data present. All right, go ahead and save that. All right, so there are a couple of more things we need to do before we start testing. And the first thing is we need to actually reset those error messages to empty string before each new request. Okay, so we're not carrying over stale messaging. So what I'm going to do is just use the setters on these and set them back to an empty string. So I'll do set withdrawal error, empty string, and same thing for set withdrawal success. There it is, and empty string. Okay, go ahead and save that. Now, the other thing that I would like to do that we haven't implemented yet is that I'd like for this input to be populated with the wallet address as soon as we sign in. So that should be a small change. Let's go ahead and do that now before we start testing. Okay, so what we can do is scroll down and let's find that input in the HTML. Should be right above the Get Tokens button. There it is. All right, so we can set a default value. Okay, default value equals wallet address. There we go, easy enough. Well, that was a lot of typing, so let's take this thing for a test drive and see how close we are in terms of getting everything working. So the first thing I want to do before I even connect is just to pop open Metamask and make sure that I'm connected to the Goerli network, if I'm pronouncing that right. Because remember, that is the test network that our smart contract is deployed to. Okay, so you definitely want to make sure up here it says Goerli test network. Okay, from there we can go ahead and click on Connect Wallet. All right, go ahead and click on Next and Connect, and that's great. I'm already seeing my account pre-populated in the input here. So I'm just going to pop open the dev console so I can monitor any logging that might be going on here. And I can see, oh, that's great, that address was being logged. Okay, so first thing I want to do is simply invoke get tokens by clicking on this button. Now let's make a prediction. What do we think is going to happen? So when we click on this button, remember Metamask should pop open and prompt us to authorize or sign the transaction, right? Oh, okay, and we see an error message right away. That's okay. And this is great that we're actually seeing the revert message right here. And this is the problem that I mentioned before that I wasn't able to get with Web3, but I am seeing with Ethers, because this is something ultimately I want to display. Maybe I don't want to display all this junk here, but I think one improvement we can make is to extract just this message right here and show that to our users. And so what we're seeing is insufficient balance in Faucet, which is totally expected. We've just deployed the Faucet and we haven't preloaded it with any funds yet, so we shouldn't expect to be able to send any tokens. So that's actually good that we're seeing that, and MetaMask is smart enough to sort of pre-calculate what's going to happen with this transaction and not even ask us to, sign it. So that's great. So we'll fix that. I'll send some money to the contract. And one other thing that might be nice is if we disable this Get Tokens button before we connect to the wallet, so that we can't attempt to send the transaction with before we're connected. So that's one small improvement that I think we can make. Let's go ahead and do that right now. All right, so let's find our Get Tokens button, and we can just add like a dynamic disabled attribute to the button, which should be pretty easy to do. So we'll go right under here, right underneath the onClick, and we'll say disabled equals, so we want to check for the presence of a wallet address, right? So say if we don't have that yet, there's no sense in showing the button or making it available to click. So we'll say false, not disabled if we do have the address, otherwise true, disabled. Okay. All right, and we don't need to test that right away. We'll test that on our next run. So I'm just going to pause the video here. I'm going to preload the contract with some funds, with some Ocean token, and then we're going to run this test again. Well, I might as well just show that part too, just in case anyone else needs to send money to, or tokens to their contract and doesn't know how to do it. So I'm just going to grab the contract address from our Faucet.js. Okay, then I'm going to go back to the browser and I'm going to click on send. I'm just going to go ahead and paste that address in. And then I'm just going to change the token to OCT. And let's do 10,000 for starters. That should give us enough to work with. I'll click on next, and that'll take a couple of seconds to a minute or two to settle. So I'll pause the video again. All right, those tokens have been sent to the contract, and I've sort of reset the state of everything here. So I'm just going to start a new test from scratch. I'll start by connecting the wallet. All right, looks good. So we'll go ahead and hit Get Tokens. Great, this time we're getting the MetaMask to open up and prompt us to sign the transaction. So far, so good. Oh, you know what? One thing we need to do is take note of how many tokens we have. All right, so I'm actually going to reject this, because how will we know if our test worked if we haven't looked at the number of tokens that we have currently in our wallet? So, and that's fine. We're getting a user rejected. I just want to take a note. So we should be getting 25 tokens. And for some reason, it is taking MetaMask a long time to open. All right, so let's go to our assets and see. All right, so I got blah, 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 699, 850, right? So I should be at 75 at the end of this test. So let's try that again, get tokens. Okay, looks good. I'm gonna hit confirm. All right, interesting. I got a success message right away, which makes me kind of nervous because it should take a while for that transaction to actually settle on the blockchain. So let's see, let's open up the wallet and see if we still have a transaction pending. I'm not quite sure what this is gonna look like ultimately. But we can check our balance. It's not going to work that quickly, I don't think. Oh, did it? Oh, I had... You know what? I think things just work a lot quicker on Goerli than on other networks or, of course, on mainnet. So that seems to have worked. I think I need to check my contract. I thought it was 25, but I think maybe it's set to 50. Let me check that. I actually have that on another machine here, so I'm going to take a quick peek at our, let's see, contracts, Faucet, and what is my, oh yeah, it is set to 50. Okay, so that is correct. Excellent. Yay, so that's great news. Our our success path is working. Oh, I'm not seeing the transaction data, so that's one thing we need to fix. There's probably just a mismatch in the property that I'm looking up, but hey, at least the tokens are being sent, so that's the main part. That's the main function of a faucet, so that part looks great. All right, so next let's look at the transaction hash and figure out why that's not populating. All right, so let's see what we're outputting from our code first of all in our success case. So I'm going to scroll back up here. All right, so we're logging the response, right? And then we're saying response.transaction hash. So first of all, let's just make sure that that exists. And if it's what we think it is, okay, so there's no transaction hash. You know, I think I may have had that in my mind from when I was doing this the Web3 way. So, okay, it's just called hash here. So that's what we need to change, hash. Okay. Well, that's an easy fix. Response.hash. Save that. What else did we say? Well, that's good enough for now. Let's just retest that part. I forgot to check if this was disabled before I connected my wallet, but I think we'll have another opportunity to check that out. So let's just try to get some more tokens. So we were at 100, so we should be at 150 as far as the last 3 digits. Let's try it. All right, confirm. And it's really nice that these transactions settle so quickly on the test network. Definitely not the case for mainnet. Usually takes from several seconds to a couple of minutes for something like this. But that was really quick. There we go, there's our transaction hash. And you know what, let's verify. Let's take this and we can plug it into Etherscan. Etherscan, make sure you're on the Goerli test network, and then we can just search for that transaction hash. And yep, there's my wallet address. That looks good. The value is 0 because that's Ether. It's not showing the actual. I wonder if we get any more details and see the actual. Oh, there we go. Yeah, there's the 50 tokens. And then the other 50 is the mining reward. Remember, if you went through the tutorial for the faucet, we had a mining reward of 50, and then, the mining reward for the token is 50, and the faucet drip amount is 50. So that's why we're seeing 2 50s right there. So that is working correctly. You know, one improvement might be to make this a link. And the only reason I didn't do that for this tutorial is because then we'd have to, like if we wanted to create a link to the Goerli Etherscan, then we'd have to, it takes a little bit of extra work to detect the network you're on and things like that, and I just thought that was a little bit out of the scope of this tutorial. But for now, we're just outputting the transaction hash, so it's easy enough to look it up. All right, so far the faucet is working great, and one more scenario that I want to test is where you do 2 withdrawals in quick succession, and the second one should fail, right? Because if you went through the faucet smart contract tutorial, you remember that we put a time limit. I think it's a 1-minute limit before you can make a new withdrawal, okay? Tell you what, let me go ahead and update that number real quick. All right, so we're showing the correct token amount. Is that going to update? Refresh. There we go. All right. All right, so let's do 2 quick get tokens within a minute so that we want to see that error message with the revert message as well. Oops, didn't mean to close that. All right, so here's my first one. And Metamask is running quite slow. I don't know if it's my laptop or what, but it seems to be taking a very long time to react to any UI input. What's going on here? Okay, I think it's ready now. Confirm. It's taking like 2 clicks to for it to actually react to anything, so hopefully it's going to work this time. There we go. All right, so our first one has succeeded, and let's try it again before a minute goes up. Oh, there we go. I think I put 2 through. Anyway, the UI was just lagging a little bit behind. But yeah, this is exactly what I wanted to see, and particularly this part right here, reason execution reverted, insufficient time elapsed since last withdrawal, try again later. That is coming directly from our smart contract. So that's perfect. That's exactly what we wanted to see. That our faucet won't just allow anyone to, repeatedly get tokens, click this thing over and over again like a DOS attack. So that's great. We've got some throttling in place, and guys, I think at this point everything is looking great. The one improvement I might make here is, we're showing all this noise. I would like to just sort of extract this string directly, just the revert message directly. So we're doing error.message, if I recall. Yeah, error.message, so that's what this is. This is error.message. It seems like this is one big string, so it may take some like regex magic to figure out a way to extract that. I don't think I'm going to do that in this video because we're already kind of getting close to an hour here. I'll leave that as an open question. If anyone feels like working on that change and submitting a pull request to the repo, I would be grateful. I will take a look at that and merge it in if it's working. So yeah, so I think we're pretty much wrapping up with this video here. Everything seems to be working great. Sorry if I seem a little bit rushed. There is literally a hurricane bearing down on my area right here in South Florida as I speak right here. So I wanted to finish this video and get it out before anything crazy happens or I lose electricity or the roof of my house blows off. So just kidding. Anyway, yeah, appreciate you guys watching this video. Again, if you enjoy this kind of content, if you got value out of this, you want to see more, I encourage you to subscribe to the channel. And yeah, again, thanks for watching and hope to catch you guys in the next one. All right, take care. Peace out. Bye.